Hello, this is my video report for Lab 2, Charge Tape Revisited. So the purpose of this lab is to observe and produce a computational model of two charged tapes exerting an electric force on each other to estimate the amount of charge on each tape and compare it to Lab 1. With this model, it's treating the tape as a series of line charges. So in our results, we found that the in the point charge model, which is from lab one, was 1.587 times 10 to the negative 8 coulombs. And the charge found in this new model, the line charge model, was to be 2.9876 times 10 to the negative 8 coulombs. So some of the fundamental physical principles, these are exactly the same as lab one. Newton's second law, acceleration of an object is directly related to net force. And this is useful for when we find the electric force because in this case, the F net is equal to zero, and that means the magnitudes of the gravitational force and the electric force are equal. For Coulomb's law, it calculates the amount of force between two electrically charged particles, which either can be attractive or repulsive. So here's an experimental overview where we basically observed the interactions between two charged tapes, tape A and tape B, and we saw how the force exerted by tape A affects tape B. So the initial conditions is that the tape mass is 0.002 kilograms, the tape length is zero point 0.2 meters, and the tape width is 0.02 meters. The system is tape B, and the surrounding is tape A and everything else. And the distance found between the two tapes was 0.034 meters. So here's the point charge model review from lab one. The initial conditions are the same in the previous slide, and the charge of the tapes were found to be Q equals to 1.587 times 10 to the negative 8 coulombs. In this model, we treated the two tapes as point charges. Here is the code for the line charge model. The initial conditions are the same, and the E field code was taken from lab 0. And this function that we see on the right is given to us in the starter code where we are breaking the tape up into n segments. And the n value I chose was 50, and it's through this function we define the tapes as a rod of point charges. And this is just the code for creating the model given to us by the starter code. And the code at the top is a nested for loop to find the electric force on each of the 50 segments on tape B by each segment of tape A. And it's through the superposition principle that those individual forces are added together to find the total magnitude of electric force on tape B exerted by tape A. Through a guess and check process by changing the value of Q, we made the magnitudes of electric force and gravitational force equate as the net force is equal to zero, and under the assumption that the two forces acting on the top tape is the electric force and the gravitational force. So since we're treating the bottom tape as a rod of point charges, we're using the formula for the electric force of a rod to find Q. L is the length of the tape and R is the distance between the two tapes. Using this formula, we're able to check the charge that we guessed in the code that makes the magnitudes of the forces equal, and the charge is found to be 2.9876 times 10 to the negative 8 coulombs. So similarities and differences between the models. In both models, the charges are found to be on the same level of magnitude, and for both of them, it's assumed that there's negligible air resistance and friction, and we are also assuming that each piece of tape has the same amount of charge. With the Lab 1 model, we're utilizing Coulomb's law, treating the tapes as point charges, but in the Lab 2 model, we're utilizing the electric force of a thin rod, having the charge distributed evenly across the length of the tape. Some possible sources of error include that the mass of the tape was calculated, not actually measured, other forces in the surroundings were not at all considered, and charges of each piece of tape may not exactly be equal. So what if you had modeled each of your tapes as a single point charge like in the previous lab? So that's what we did in lab one, where the point charge model that we used found Q to be 1.587 times 10 to the negative 8 coulombs. And with the new model, the line charge model, we found Q to equal to 2.9876 times 10 to the negative 8 coulombs. So there's definitely a difference. The line charge model is greater than the point charge model. So why do these estimates differ? Which value is more likely to be closest to the real value and why? So the differences in the estimates is due to the different methods of calculations. And it's likely that the line charge model is closer to the real model because it takes into the account of the length of the tape rather than simplifying it to a single point charge, which isn't accurate at all to what it is in real life. But yeah.